Hi, my name is James Fengos. I'm from Francis Lewis High School, and my experiment tests the effects of coconut oil and fish emulsion on the growth rate, quality, and yield of Raffinus sativus under water stress. As for my reasoning behind this project, radishes face challenges under water stress, which negatively impacts both their growth and their nutritional value. This critical issue with radishes makes it so that when conditions are even slightly unfavorable to their growth, it can lead to a big difference in the actual nutritional outcomes for the plant and crop yield. This is where coconut oil and fish emulsion have the ability to come into play. Both of these treatments are low cost and accessible alternatives to chemical fertilizers, and they have the potential to work together, which will be discussed later, and help these plants cope with water stress, being the lack of water when growing. The potential synergy between these two organic substances may lead to a significant improvement for radishes to resist unfavorable growth conditions and maintain their nutrient and crop outcomes. As previously mentioned, radishes require consistent moist and wet soil to grow properly. Without the presence of this, water in their root structures may lead to the decline of root systems, leading to the plant being able to stop from expanding cells, leaf growth slows, and root systems remain underdeveloped. In the past, several organic treatments have been used to remedy this issue, with some succeeding in improving the growth of radishes. However, most of these studies only look at growing conditions when radishes are in wet soil and have proper sunlight, meaning that less scientific studies have focused on different treatments affecting radishes under harmful conditions such as water stress. And that gap in the research drives my project and shapes the direction of my work. As for the first treatment in my experiment, coconut oil was selected to be assessed on improving radish growth conditions under water stress because of the moisture retention properties that it holds. When used in low concentrations, coconut oil has been found to reduce the evaporation rate of water in soil, meaning that it allows for a greater amount of water retention to be used by plants. Additionally, the high amount of medium fatty acids that coconut oil holds makes it so that coconut oil can strengthen the soil that these radish plants grow in, making water retention greater. These plants could then use that water to grow and maybe increase the nutrient outcomes under low water conditions. For plants that decline rapidly under dry conditions, even small improvements like these can have a potentially meaningful effect on their growth. Additionally, the growth of the plant could be supported by another fertilizer, which is organic, called fish emulsion, which provides an accessible source of nitrogen and different essential nutrients and essential elements that radishes use during their early development. Because it's absorbed so quickly by soil, it promotes the strong growth of roots and leaves in the plant, making it so that fish emulsion has the potential to prepare the plant to withstand water stress later on in the growth cycle because of its effects helping radishes grow early on. With these aspects of the treatments, combining these to potentially enhance the growth abilities of radishes could be promising because fish emulsion has been extremely useful in previous studies when looking at the ability of radishes to withstand water stress. And this brings me to the gap in my research statement, where although both materials are frequently used by farmers, almost none of the research presently looks at the combined effects of these growth treatments or any growth treatments on radish growth. Additionally, less research shows how different treatments can affect the outcomes of these radish plants under water stress, meaning that this is an area of radish and plant science that hasn't been explored too often. And this leads me to the missing question in my research, which is whether combining these moisture retention properties of the different treatments and their nutrients into the soil could mitigate the effects of water stress and create kind of a synergistic effect between the two treatments, leading to a greater effect than if either of them was used independently. As for my experimental setup, I created four groups of radish plants, and each group was controlled to water stress and without water stress. And these treatments were a control with no coconut oil or fish emulsion, a coconut oil group, a fish emulsion group, and a combination of these two, where the individual concentrations of coconut oil and fish emulsion were lowered to ensure that each group received the same amount of nutrients and that the synergistic group did not just receive more nutrients. These groups allowed me to test whether the actual synergistic effect of these two treatments had a greater effect than if the two treatments were used alone. Additionally, watering occurred on the same day, which was a Tuesday and Thursday throughout the week, and the plants were watered according to their group type. So if they were in a water stress group, they received half as much water as a non-water stress group. In my experiment, I measured 4 key variables: plant height, number of leaves, root diameter, and biomass, which was measured by the fresh mass of the plants and the dry mass of the plants after incubation. I also documented changes in leaf color, firmness, and the wilting patterns of each of the plants, but because these variables could not have been quantified in my experiment, they were excluded from the results section. And these variables together provided a clearer picture of how different treatments and growth conditions affected radishes, as well as how radishes were affected when their water became limited, and how each of these treatments provided a change in their tolerance to water stress. As for my results, the first part of my results section documented the plant growth of the radishes under different treatments, and the results from these trials showed that the combined treatment produced the strongest across different variables measuring growth, such as height, the number of leaves, and the biggest root diameter. As you can see in the graphs, the combined treatment had a significant increase in the height and number of leaves of the plants in non-water stress groups, and water stress groups will be discussed later. Coconut oil additionally had the second highest height of the plants, and it caused increases in the firmness and the water retention in the soil, making it a good treatment when measuring the effects under water stress. Additionally, the second part of my results shows more of a synergistic outlook on how these two treatments affected the plants under water stress. When combined, fish emulsion and coconut oil produced a significantly higher wet mass and dry mass, although not shown here, of the plants. Additionally, when looking at the leaf color of each of these plants, a lower score was indicative of a better leaf color. And as you can see from the graph, the coconut oil and fish emulsion groups under water stress and non-water stress conditions caused a significantly lower leaf number quality score, meaning that the leaf quality was better in many of the plants in this group. The coconut oil throughout this experiment led to an increase of moisture retention and a slower drying of the soil, while fish emulsion was consistently shown to boost the nutrients and lead to a higher height and number of leaves in the plants. Additionally, the combined treatment led to the most significant outcome on growth. Under water stress, these two graphs show the different growth variables measured and their effect by each of the treatments. And as you can see in the graphs, coconut oil plus fish emulsion led to a significantly higher increase in the water stress groups than anything else, while coconut oil alone was just slightly behind, although there was a significant difference between the two groups. This shows that although coconut oil can improve the water retention and the growth of radishes in soil, it may not have the same effect as when coconut oil is used in combination with fish emulsion. When interpreting these results, we can see that the moisture retaining effect of coconut oil created a good environment for the roots to grow in, creating healthy root systems, allowing for better growth in the plants. Additionally, fish emulsion led to increased leaf growth early on and led to a higher growth of the plants. But their combined effect had the most significant growth increase throughout all of these treatment groups, showing how it is by far the best treatment. The impact of this on farming is that coconut oil and fish emulsion are both low cost and easy to mix treatments. And these are ideal in areas which have unpredictable rainfall or do not have that much rain throughout the year. This helps communities of like gardeners or farmers or even school projects succeed with limited resources, which reduces the reliance on chemical fertilizers or synthetic fertilizers. These can all help yields and growth of plants for small farmers and farms. The significance of these results may be that organic fertilizers and substances can be combined to create stronger responses than synthetic fertilizers, meaning that radishes can grow more easily and better with cheaper organic fertilizers. Additionally, radishes serve as a model for other crops, meaning that if these results apply to radishes, they might apply to other crops as well. The limitations for my study, however, were that I had a limited sample size, an indoor environment, and only one concentration per level of treatment. So studies with more resources may have a greater time exploring the effects of the coconut oil and fish emulsion in combination on radishes. Additionally, the soil composition was standardized, which doesn't show the limited soil in other areas of the world. Future research opportunities in this area can test multiple concentrations of both of these additives. They can expand trials to different plants and observe the long-term outcomes, as my study only tested the short-term outcomes of these treatments. Additionally, outdoor growth or exploring whether coconut oil affects the microbial environment in the soil over time may be an area of future research. Thank you for listening to my presentation. If you have any questions, you could contact me at the email below.